Okay, welcome back. Today we're talking about prime factorization, and first, as always, we're going to go over some key vocabulary words. So first of all, a definition of a prime number. If you'll write this down, it's a whole number that can only be divided by 1 and itself. So a prime number, whole number that can only be divided by 1 and itself. I'll give you an example. The number 2. Okay, 2 is a prime number because if you want to find the product of 2, you can only go 1 times 2. There's no other way to do it. 2 can only be divided by 2 and by 1. There's no other number for it to be divided by. A composite number, on the other hand, is a whole number that can be divided evenly by more than 1 in itself. By the way, I should have written evenly here too. Divided evenly by 1 in itself if you fix that. An example of a composite number then is like the number 4, okay? Because there's more ways to get the product of 4 besides 4 times 1. You can do 2 times 2, for example. So 4 can be divided evenly by 1, it can be divided evenly by 2, it can be divided evenly by 4. So that makes it composite. Okay, come over here to the factor pair real quick. Factor pair are two numbers that multiply to get another number. So for example, factor pairs of 4, 2 times 2, that's a factor pair of 4. Because you multiply those two numbers together to get another number, you get 4. Okay, and the purpose of these notes is to understand prime factorization, and so the definition of prime factorization is a number written as a product of its prime factors In other words, we're breaking apart a number until you get to all of its prime factors, and you're going to understand it better as we do an example of it. A factor tree, by the way, is simply a diagram with prime factors. It's just a way to organize your work when you're doing prime factorization, really. Okay, so let's go over the steps of doing prime factorization. You draw, step number 1, draw 2 branches under the number you are factoring. So in our example here, we've got 48. I draw 2 branches. Number 2, find a factor pair. Well, we said a factor pair is when you multiply 2 numbers together to get another number. So we need to come up with 2 numbers when you multiply them together that you get 48. I'm just going to choose 6 times 8. So 6 and 8. I put a 6 under one branch and 8 under another branch. Number 3, write the factors under the branch. That's what we just did. Write each factor under a branch. That's your 6 and your 8. Number 4, continue factoring until each branch ends at a prime number. This is why it's important to understand prime numbers. So in other words, 6, can you think of 2 numbers that multiply together to be 6? I can, 2 times 3. So we make 2 more branches and we have 2 and 3. Okay? By the way, the final step is to circle the prime factors at the bottom of each branch. So There aren't any more factor pairs of 2 besides 1 in itself, so this is prime. Same with 3, only 1 in itself. We can't factor it anymore, so we circle it. Now 8, two numbers that multiply to be 8, 2 times 4 make 8. 2 once again is a prime number. 4, I can still think of 2 numbers that can be multiplied to make 4, 2 times 2, which are both prime. Okay, so we've done prime factorization. It says a number written as a product of its prime factors. So this number 48, and these are all the prime factors of 48 that we have circled. Okay, so if you were to finish the prime factorization, this literally says to get 48, you could go 2 times 3 times 2 times 2 times 2. But if you remember yesterday's video, we went over powers and exponents, and we can rewrite this in a more simple way so it's not so confusing. We can organize it, if you will. If you notice, for example, there's 1, 2, 3, 4 2's that are being multiplied together, right? So our base is 2 to the 4th power is the same as 2 times 2 times 2 times 2. A simple way to put it, 2 to the 4th power. There's only one 3, so times 3. We just got the final prime factorization of 48. Why? Because when you go 2 to the 4th power times 3, you end up with the answer. The value is 48. Okay, we made here a factor tree with our branches, and we concluded with the final prime factorization of 48. All right, let's do a couple of problems together. Problem number 1 is 42. So our first step, draw 2 branches. Let's draw 2 branches. Can you think of 2 numbers, when you multiply them together, you get 42? There's different ones that you may know. I automatically think of 6 times 7. Okay? And we keep factoring until we can't factor anymore, right? Until the numbers become prime. So can you think of 2 numbers that when you multiply them together you get 6, besides 6 and 1? I can. 2 times 3. Okay, can we factor 2 anymore? No. The only factors of 2 are 1 and 2. 3, it's at its prime because the only factors it has are 1 and 3. 7 also is already prime because the only factors of 7 are 1 times 7. So we have done our factor tree all the way down to its prime numbers. So now we just need to finish the prime factorization by putting these in order. 2 times 3 times 7, and we are done. I put a box around it, rectangle if you will, to show that I finished that problem. Okay, next one together, 16. Once again, it doesn't matter which 2 numbers you choose. Choose any 2 numbers that multiply to be 16, you'll get the same answer in the end. I draw my 2 branches. I think of 4 times 4, okay? And I know that 4's can be factored more than just 4. 2 times 2, right? So I draw 2 more branches, 2 times 2, same with this 4, 2 times 2, and as we learned in our notes, 2 is a prime number, so we can circle all these 2's. And what is a simple way to write 2 times 2 times 2 times 2? Well, the base is 2. How many times are we doing it? 4 times, so 2 with an exponent of 4, or 2 to the 4th power, and we are done. The time is yours to turn the video, to pause the video if you will, and to try to do the prime factorization of 54 and 90. Okay, have fun, and have a great day.